without further ado, let's get started. WebTransport. The WebTransport protocol framework enables clients constrained by the web security model to communicate with a remote server using a secure multiplexed transport. So it's like WebSockets. If you're familiar with WebSockets, it's not supposed to be high level. This semantics is supposed to be provided by the application, and it's supposed to be safe to be used without any kind of explicit authorization from the user. What's different from WebSockets is that it's over UDP, not TCP. It avoids head-of-line blocking, and it supports datagrams as well as multiplex streams. And stream creation is essentially free, as opposed to WebSockets, where there are several round trips to create a new WebSocket, and it involves an HTTP style handshake. So QUIC transport is WebTransport over plain QUIC. So there's no HTTP involved. This is just the QUIC protocol as standardized by the IETF, and not the HTTP3 protocol, which is layered on top of QUIC. And this is what we're initially focusing on. And then there's HTTP3 transport, which is the same thing, but over HTTP3. And that means it can use an existing HTTP3 connection, which is useful if you happen to have one. And multiple HTTP3 transport connections will be able to be multiplexed over a single HTTP3 connection. But as I said, we're first focusing on QUIC transport because that's where we see the most immediate demand. So I'm going to explain a bit about head-of-line blocking. So if you've got some data being sent in order, then it has to be received in the same order. And even if you don't want the first part of the data anymore, you've got no choice but to receive it. And this is bad for latency sensitive applications because they usually want the most recent data rather than the first data that was sent. So this diagram, if you imagine that this is the browser, there's some kind of game running in the browser. The browser is sending a bunch of messages to the server to report the moves that the player has made. And this red message has been lost in transit, so it needs to be retransmitted, which is going to take some time. But actually, the only messages the server is currently interested in is the green message, which is the most recent message. So this is the problem with head-of-line blocking. You get stuck behind messages you're no longer interested in. Is that a reasonably clear explanation? Okay, good. Because I'm going to talk about the solutions that QUIC transport provides. Firstly, datagrams. They're unreliable. They may be delivered out of order or not at all. Limited to about 500 bytes, depending on the MTU of the connection. And so if some data, if the first data is delayed, then later data will still be delivered. And this is supposed to demonstrate a similar scenario, but this case using datagrams. So you can see the first one has been lost, but we don't really care. The second two are delivered, but we're not interested in them anymore because the final one is the most recent one and has been delivered. And they're all essentially sent in parallel. Obviously, the ones you send first are more likely to arrive first, but think of it as in parallel. The other solution, oh, sorry, skipped a slide. So this is an example of how the protocol is used to send datagrams. So you use the send datagram method to get a writable stream. You then write the datagram to the writable stream. In this case, it just contains the text "hi." And that's all there is to using the Datagram API. There's also a second solution to head of line blocking using streams. So streams are partially reliable, meaning that they're either delivered completely or not at all. The major benefit over datagrams is they have unlimited size. And since they're cheap, you can use each one as an individual message. However, they're not free. So datagrams are still cheaper. So if you only need to send 500 bytes anyway, then you may as well use datagrams. But if you don't know how long your messages are going to be, then sending each one as an individual stream ensures that you can send a message of an arbitrary size. And here's I changed this earlier. This is an example of using the Stream API, and it looks very similar to the Datagram API. But if you can imagine that each message is like longer than 500 bytes, that they've actually been split down the middle. So each message is actually being sent in multiple UDP packets, but they are correctly assembled at the destination server. And so each stream arrives in order with reliable delivery, but the streams themselves are independent of each other. And so this is how you'd send a single message using this API. And it's really quite similar to the Datagram API, except in this case, rather than having a stream where each chunk is a separate datagram, we have a stream which is a stream, sorry. So you have basically one stream per message. Every time you want to send a message, you create a new stream, send a message on it, close it. You can send multiple chunks on the stream. They're not limited to just one, but these are binary chunks. So a uint8 array or some other kind of array buffer. And this is how you connect with QUIC Transport. So we have a QUIC Transport URL scheme, which we've just registered last week. And once you use the onState change event handler to detect when you've actually succeeded in connecting. And there's also a state getter on the QUIC Transport object, which tells you what the current state is. So in this case, we're only interested in the connected state, but there's also closed and failed states and a connecting state as well. So current status, QUIC Transport is available behind a flag, but doesn't actually do anything yet. I say that it will, if you pass an invalid URL to it, it will throw an exception. But if you pass a valid URL to it, it will do nothing at all because the service side isn't hooked up yet. So it sends a Mojo message, but then the Mojo message isn't handled. It's under rapid development. We haven't nailed down all the aspects of the JavaScript API, but the underlying QUIC API seems to be in a good state. And I think, is the IETF meeting last week or next week? Next week. So it's being discussed at IETF next week. So that should make it even more concrete. And we're aiming for an origin trial in January. And okay, so this slide is just for reading, not really for talking about. Basically, it's a fairly common servicified pattern where the network parts are in the network service and the Blink parts are naturally in Blink. So for testing, we're using web platform tests, or will be. But web platform tests only have HTTP servers at the moment. There's a experimental HTTP2 server, but nothing for QUIC. So we couldn't actually implement the QUIC server in Python. I think the TLS libraries that come with Python are too old. They don't support the a sufficiently new version of Datagram TLS to be able to implement QUIC with them. So instead, we're going to ship a binary server with the web platform tests. So basically, there'll be 3 versions of the binary server for Mac, Windows, and Linux. And then it will use Python handlers to have the specific behavior that we want. For example, one Python handler would just echo back anything you sent to the server. Another Python handler would refuse to accept your origin and test various other edge cases of the protocol using various Python handlers. And this is a list of the standards. This, again, is a slide for following the links later rather than reading. And these are the people who are working on this. So Victor Vasiliev in Cambridge has been doing most of the work, I would say, is writing the spec, implementing it inside Quiche. Quiche is an implementation of the QUIC protocol, and writing a test server implementation, which I think just landed this week in Chromium, but it's not yet landed in web platform tests. And Yutaka Hirano, who's sitting there, is writing the network service and Mojo parts of the implementation, and I'm writing the Blink side implementation. So that was slightly too fast. Questions and discussion? Yes.
So I think I pick up the idea that you're sending small data, use datagrams, big data, use streams. Guessing it is like based on the size of individual. It is like a datagram one packet.
Yes, a datagram is exactly one UDP packet. You can actually ask what the MTU of the connection is, so you can actually know how big of a datagram you can send. But in general, I think you're going to decide based on your application. Apparently, a lot of games I've heard use like actually quite small datagrams, like 120 bytes or something like that, and so they will always fit inside a single packet. I think if you don't know that you're going to fit inside a single packet, you will probably use streams, but you could try to do something clever and use datagrams for small packets, streams for large packets. You could even write your own packet reassembly algorithm, since it's quite a low-level feature. That's the sort of thing you can do on top of it. Sorry, I should... Does anyone want a microphone?
I think we are supposed to talk into microphone to have our voice recorded. So you can just repeat the question. Right?
I forgot what the question was.
Okay, give us the microphone.
Not okay. Anyone else want a microphone?
Yeah, so this might be a question for Yutaka, but I'm curious if the new QUIC stuff is going to use the URL loader network service interface, or is it going to have a new one, kind of like WebSockets?
It is not using URL loader. It has a dedicated module interface.
Got a question as well. Will there be any proxying support?
No. Having said that, the HTTP3 transport, if HTTP3 proxies are specified, it could use one of them. But it wouldn't really make sense to put it over an HTTP or HTTP2 proxy, because you'd lose the benefit of having no head-of-line blocking. In that case, you'd have the head-of-line blocking. So this means it's not going to work in all environments. Depending on the application may implement a WebSocket fallback to work in more environments, or it may just decide that in environments where you're stuck behind a proxy, the application is just not going to work.
So you mentioned earlier that you're starting with QUIC because that's where the demand was.
Yes.
Can I ask who's asking for the feature?
So we have people.
Okay, so secret stuff. That's fine.
I'm trying to work out how specific I can be. Game engine developers are interested in the feature. Are you going to?
Yeah, so as sort of a general case, there's been a desire for a better version of WebSockets, specifically versions of WebSockets that do not have head-of-line blocking, and this comes from sort of the usual suspects in games and media and other sorts of streaming applications that don't need to be named but exist. And so, yeah, the ability to do a sort of UDP-like transport on the web is something that developers are looking for.
So do you have any specific use case which needs not just one diagram, but for like streams? So I can imagine there is a demand for diagram to avoid head blocking, but I'm not really sure what's the use case for streams.
So there are media use cases where the streams are very useful. In general, you're going to get better performance than TCP/IP just because QUIC has more advanced congestion control. There will also be some statistics. You'll be able to get statistics from the protocol layer, which will tell you about the congestion control, tell you about what your expected bandwidth allowance is, so that you can adjust like the rate of your video streaming, for example, according to how much bandwidth is actually available. So that's, I guess, a couple of reasons why you'd use the streaming interface. Yutaka?
So there is a demand for the multiplexed WebSocket. So you can use the streams interface for such use case. So for WebSocket over HTTP 2 is specified, but it still has a head of line blocking problem. And this one, the quick transport, won't have that problem.
So that means you are you want to deprecate some part of WebSocket, or it's kind of case by case, which one use, which the best for the, basically that's the user's choice to have.
Yes, that's the user's choice, I think. And there are some environments where QUIC cannot be used. So in that case, WebSocket may be a better choice.
So yes, WebSocket has the benefit of working in more environments and also having a large deployed base of existing infrastructure. I expect in the long term, quick transport will provide better performance, and so people will use it preferentially. But in the short term, like in the next decade or so, there'll still be a lot of WebSocket use.
So since you are going for an origin trial in January, I suppose that the implementation status in Blink and Chrome is pretty advanced. What about other browsers?
So there's no implementation that we're aware of. There has been discussion, I think, with other browser vendors. We're not just going it alone, but we'll be the first implementer.
I guess I was in TPEC, and I think Harald and Peter did talk about this one. I think Firefox had expressed interest, but I don't know the.
Yes, I think they've spoken about it. Any other questions?
Testing. Okay, cool. Have you thought about or done any support for DevTools with this new feature yet?
DevTools, I have got to the point of thinking about, yes, we should have some. One of the plans we think to do differently from WebSockets, currently DevTools will record every WebSocket message that's sent and received. So that effectively means when you have DevTools open, A, WebSockets are very, very slow, and B, it fills up your memory quite quickly. So we're thinking of not doing that for quick transport. It would be interesting to have like a circular buffer of the most recent messages that were sent and received. So, and obviously we will actually have to display either in the network tab or somewhere else what quick transport connections are actually open at the moment. I think that's something we will need. But in the first Origin 12 version, there will basically be no support at all. But yes, that kind of invisibility is not ideal. It would be better to have some visibility to developers. So we're certainly planning to do something. We just don't know what the something is yet.
Yeah, I echo your concerns with the performance things because there's a bug with many stars open about how WebSockets are slow in DevTools.
Yes.
Not quite a question, just a statement. I'd like to mention that for some category of users, lack of DevTools support can actually be a feature.
Well, we will have that feature in the Origin trial, so we'll see how it works out. Anyone else?
You mentioned you will expose PathMTU to the client. Are there any other low-level connection properties you're going to expose to the client script?
In the case of QUIC, we can expose quite a lot. So I will try to quickly find the right. So these are the stats we will expose for QUIC, or that we're currently planning to expose for QUIC. So the round trip time would be, and the number of dropped datagrams would be interesting things. This is kind of in flux. We may expose more or less than this. For HTTP3 transport, it's much harder to expose stuff because the connection will be shared with other things which may not be visible to the page. So probably there will be no statistics or very limited statistics available for the HTTP3 transport. So in that sense, the quick transport gives you more control. Right, I think we have, only 4 minutes left. Right, so I think we can probably finish if there's no other questions. Does anyone want to talk about any use cases they might have for web transport or any other network protocol? No one is offering. Okay, so I think we have quorum to finish the session now. Thank you very much.